Welcome back to our brand knowledge channel. Today we are going to learn all type of control chart. There are 7 type of control chart. 3 are coming from variable chart and 4 are coming from discrete chart. All 7 control chart we are going to learn today. And the good news is that we are going to take the sample, free sample directly from Minitab. And this is the detail combining all the cases, 7 case study of all control chart. Not only that, we are going to discuss box Cox transformation that will become 8 and Laney P chart, Laney U chart also as well. To put together 7 plus 1 plus 2, 10 control chart we are going to learn. But formally we have only 7 control chart, but we also have an extension version of control chart like box Cox transformation, Laney chart and all that we are going to learn. If you go to Minitab, if you open the Minitab, in the system menu, you will find that this has been outlined. If you have a continuous data, first of all, if you want to know what is data type, continuous data and various variable data, just have a click on this. Continuous data is anything which is measurable. A food manufacturer want to investigate whether the weight of the cereal product is consistent over time, right? You can measure it. Anything which you can measure, obviously it's called continuous data. Attribute data is something which you can count or classify. Count the number of defective or the number of defect per unit is called attribute data, right? So because based on the type of data, your control chart will vary. So first of all, we need to understand as a prerequisite that what is the type of data we have. One is continuous data and one is attribute data. In continuous data, you have a 3 chart. One is if you don't have any subgroup, straight away one subgroup, then you can use IMR, individual moving range chart. If you have subgroups like X bar R chart and X bar S chart can be done, but X bar R chart is a better tool to use it. Whether even if you have a subgroup greater than 10 also, we can use X bar R chart. We are going to learn this also as well. Okay, when it comes to discrete data or attribute data, again in attribute data, you have a good example here. You can see wherever this color has been there, what is meant by subgroup. For example, when you say subgroup, have a click on this. This is batch 1, batch 2, batch 3. All we are measuring only pH value, right? And when you have a subgroups, mean what it mean? Multiple observation collected close together in a time. For example, let's say diameter and of a different thing, this is relating differed by batches, different by supplier, different by all different type 5 consecutive rims are there. All that when you have over period of time, then you can use X bar R chart or X bar S chart. Similarly, you can find subgroup furthermore here. First, it given that what is meant by subgroup and subgroups, right? It has given that if the data is not collected in subgroup, what is that chart we can use? That is IMR. If data is group, you can use X bar R chart, X bar S chart. Further classification has been given. If you can click here, and if you have subgroup in 8, right, 8 or less or greater than 8 also, we can use X bar R chart now. And greater than 8, you can also use it. Then here it is given that very good explanation about what is mean by, for example, 10 cans you have every 30 minutes is being measured and all that. Then you can use X bar S chart or X bar R chart. We'll see in detail. And similarly, if you're having that defective and defect is very, very important dimension from the control chart standpoint. Defective is each item is classified into 1 or 2 categories like pass fail, defective, non-defective. You can count or you can classify, right? You can get the percentage or proportion, right? And automatic inspection example, bold, right? Pass fail. Only you have a binary decision. Defective is something one defects can have multiple defective. Each item can have more than one defect, right? Undesirable characteristic. For example, defect may include tear, scratches, puncture, right? So one shirt can have multiple defect, right? So therefore, 5 shirt may have a more than 5 defects. This is very good example. And then if you have defect, you can use C chart and U chart. And C chart is C stand for count and U chart. If you click on count, again, you will have a U chart. In the U chart, you will find an examples and all that. we'll see in detail the number of non-conformity in a unit, and P chart for proportion, and similarly you have NP chart. So so this has been added. The NP is here and C is here. So put together we have formal 7 control chart, right? And let's start with IMR chart. So to do that, all the control chart is there in this bucket called stat. Go to stat and you'll find control chart. You have all the control chart like box cox transformation, variable chart for individual, attribute chart, time weighted chart, multivariant chart, rare chart, all that is here, right? So we are going to discuss all the main chart, although we'll be touching this rare chart and all that in different videos, but the length of video might increase much. So therefore we'll stick to the formal or broad classification of control chart. So we'll start with IMR chart. Go to IMR and you can click on help menu, and so that you can take the example, you can click on example. So here, as the distributor manager in a limestone query, you want to monitor the weight is actually measurable data, and variation in 45 batches limestone that is shipped weekly to an important client. Each batch should weigh approximately 930 pounds. You previously created moving range chart. Now you wanted to understand this one. So you have weight and EXH QC. Wherever EXS is there, Minitab has more sample to it, right? So EXH QC.mtw, we can find it this one. Okay, so what you can do, you can just go and as an outset, I also wanted to add one point. Whenever you are dealing with the variable data, normality test is important. When you're dealing with the discrete data or attribute data, normality test is not applicable. So therefore, I will start with EXH. As we did it, we'll take that EXH QC, and maybe we have done that IMR, and we have learned that the file name is EXHQC, right? The same file, we'll take it. Go to file and go to open worksheet. Look in Minitab sample data folder, EXH, right? QC. This you can open up. It is there in the Minitab 17 version. If you're using it, is here. If you're using greater than 17 version, you can just go to support.minitab.com. You can just type that file name. It will automatically come. For example, if you're using version number 21 or 22, you can easily do that. Now, directly I'm taking from the Minitab. So this is the file. Here, we have been asked to measure only the weight. Although there are a lot of other set of data is there, this has been measured with respect to different batches, right? So there are three different batches are there, right? We'll go to first thing. What we have to do is whenever you're dealing with the measurable data, so first thing to check is normality. Normality can be done through the graphical summary or through the normality test. So we can go for normal graphical summary that will give you quick information. Okay, just have a click, and then weight is C6. Okay. So you can see that nicely it has come, the bell curve has come 22.6. The data is normal, right? And now, once we concluded the data is normal, you can see the mean values here, standard deviation, variance, and kurtosis, skewness slightly positive dominant. You can see 936 if somewhere here, and then right side is quite slightly dominant, and kurtosis value you can find all that, right? Now we can directly go for normality. Since we have done the normality test and found that normality test is being okay, then directly we can go for IMR. So in IMR, I'm just checking that weight, and in the scale, if you wanted to stamp, this has been there in the different batches, right? So shift, maybe I will click on shift. And if not, Minitab will take it as 1, 2, 3, 4 and all that. Index as a 1, 2, 3. And then label, we can give a titles and all that, subgroup, and you can give if you wanted to have the same. And similarly, you don't need to disturb here, and then you can go to IMR. This is a couple of things you have to do. In estimate, if you wanted to omit anything, we can do that. Or limit you can set up. For example, let's say 1, 2. That way you can do it so that it will give. Otherwise, you can just leave it. And test, you can perform all the tests. So please note, for IMR, any variable chart has got 8 interpretation rule. So 1, 2, 3, 4, 1, 2, 3, 4. 8 interpretation rule exists for the data, if the data is variable data. The weight is a variable data. So therefore, 8 interpretation rule also, not only we should look for an outlier, but we should also look for a special, all the 8 interpretation rule also should clarify, right? So now let's go further. Give OK. So you can see that this has an outlier, and you can see the outlier is here. This is the X bar. Let me explain that how this limit has been calculated. This is an average 936 gram, and then you have a lower control limit 862, and upper is this one. This is going beyond that one. Rule number one, all rule number one is outlier, right? So it is failing in the upper side and lower side. We can conclude the process is not stable. And then there is also moving range problem also there. You can see here. So how the moving range is being calculated is that each range has been taken. For example, let's say if I convert that data, if I take this data and put up in Excel, you can find that 930 minus 905 is 25, right? So you will find that in the Minitab, you will find 25 is the moving range, right? So similarly, you will find the next value. You can see here 25 and the next value and all that. The range inter range is 27 gram of difference is there. So this precision also problem and accuracy also problem. Okay, and this process is not stable. This is all about IMR. If you wanted to do by not only you wanted to stamp by the shift, but you also want to stamp by the value, you can also do Control E, and you can go to stages. In the stages, you can put like shift, right? You can easily convert that one. So this is all. Since we have already done it, we don't have much batch, so we can just leave it. Okay. And if at all, if you have more equal batches, we can also do it. So this is how the IMR has been there. Let's go to the next chart. And the next chart, what we have is called subgroup one. And we have X bar R chart and X bar R chart. Just click on X bar R chart, go to help. You will find an example here. And in the example camshaft, we will be taking it and we'll be taking with the five subgroups, right? There are 5 subgroup is there that we are being entering for these 5 subgroups. Okay. And let's see camshaft. You just copy this one. If you don't find it in the Minitab, you can go to minitabsupport.com. You can find that file also as well. I'll keep the link in the description also. File, open worksheet, and look in Minitab sample data folder, and you can just click on camshaft. No, camshaft is there, and this is the data. You can find it here. Like one length is given, supplier 1, supplier 2, and so now let me double check again. So they ask like what is the, now we can use a supplier instead of length. I will put like supplier 3. That will be better, right? Supplier 3, I can use it. And again, normality test we have to do, but in this case, instead of doing one by one, I can do directly through this method called probability plot. In that multiple one, I can have a select. I can select 1, 2, 3. All this one I can give. Let's see whether the data is normal. So all the first data is not normal. So the p-value is less than 0.05. Another one is also not normal, and the third one alone is normal, right? So maybe so what I can do is that still I'll believe that this is due to normal, this is due to natural cause and all that. Still, I will add the disclaimer, and then I will still continue to do the IMR, I mean X bar R chart. So go to the control chart, and you can put like X bar R chart. In the X bar R chart, you can see here. Okay, and you can see all the values. We can just have a select and subgroup. We have been told that it has been done in 5 batches. And in the X bar R chart, we're going to select all the tests. Give OK, keep OK. You can see that the value set has come for each supplier. You can see supplier 1, supplier 2, and supplier 3, right? So supplier 1, no outlier, fantastic. Supplier 3, there are an outlier, and no. And then supplier 1, this is IMR that we can skip. And this you can see here, X bar R chart for supplier 1 and 3, you can find it here. Where is 2 is gone. So let's figure out. Yeah. So 2 is here. Yeah. So 2 is also there. So this is how we can easily do it. Now we can conclude the things very fast. Let's say if you want to divide by stages, uh, you will not be able to do. But if you wanted to check by, you have in some subgroups and all that, if you have reference, you can do. And similarly, like we know that the data 1 and 2 is not normal, you can do the box Cox transformation directly from here also as well. But I'm not doing it because I will do it separately for that. So X bar R chart is also done. Let's go to the next one is called X bar S chart. And again in subgroup X bar S chart, click on X bar 1 and you will find an example, and the blood sugar example is there. A subgroup is they have given 9. 9 subgroup is there, and we have to monitor the glucose level, right? Glucose level, again, I'm just going to file, look in Minitab, open worksheet. I'll look in Minitab sample data folder, and you can just glucose.mtw. Open that. So this is new and standard, and we've been told that this has been done in 9 batches. So, right? So we can easily do that also. Go to stat and let me read the question again. Yeah, I will come back to this worksheet. Let me read the question again. Control chart, subgroup, and X bar yes chart. And this is the one. Example, so you're conducting the study of blood glucose level of 9 patient, okay, 9 patient, and who are strict diet and exercise routine to monitor the mean and standard deviation of the blood glucose level of your patient. Create X bar yes chart. We have to use. You take the blood glucose reading every day for each patient 20 days. So 9 patients we have, and then each day it is taken like 20 days it is taken. So so this is how the data is there, and blood sugar, and we can go for subgroup and all observation in one column. Yes, this has been stacked in one column, and we can give subgroup as 9 and give okay. Yeah, glucose. Yeah. Okay, now we have read the questions. So X bar R chart in one column, yes. And I will take that standard or new, we can take it. We will do for both. And 9 subgroup it has been done. And you can just go to this the test, perform all the test, give okay, give okay. So you can see here, so this is sample, and how many, whether the very stable, it looks to be very stable. Let's do it for new also as well. So for new also X bar, yes chart is there. 16 is the standard deviation, and 91 is the glucose level, and this also we can do it. So, and you can right click and go to the stat. You will find the same thing, X bar or X bar yes chart, but the example which we saw was for the X bar yes chart, right? So X bar yes chart also we have seen, and there is another sample also they have given, and canning also as well. We'll do that canning example also as well. One more sample we'll take it of canning also as well. Canning company want to assess whether or not its can filling process is in control. 15 subgroup of 10 cans, 15 subgroup of 10 each were collected in 15 minutes interval with the shift and single day production to minimize the within the variation can to can variation, the 10 samples being used. So will take that canning also as well. One more additional sample of X bar S chart. So go to this, look in Minitab data folder, just type CANNIG canning and give okay. So this is the weight is there, and this has been done in 10 batches, right? So X bar again you can do in this has been done in the subgroup. We can also highlight those subgroup also as well, like here each batch has been done in 150, right? So you can also give that disclaimer also, so that it will be easy for you to add that. So subgroup, although it is only one, but we have been told that it has been done, but it's been stacked all together in one column, but it's been done in 10 batches. So X bar S chart and are in one column. Yes, it's only one column. We can say wait, but this has been done in 10 batches. So test, perform all tests. Good. Okay. Let's see whether the values are there. So you can see here The same graph we got it here also as well, right? The same graph we got it. So this has been done in 10 batches, and so what is the variations and how much variation we can easily study and do it. So this process is not stable. Rule number 6 is failing. Rule number 1 is outlier. Rule number 5, see what is rule number 5, and we can 5 and 6 is failing. 1, 2, 3, 4, 5. That means greater than 2 standard deviation is there, and greater than 1 standard deviation is there of 4 points, right? So these two, all the variable chart we have successfully completed. And now let's go for discrete chart. Okay, go to stat, and in the discrete chart, we don't need to measure any variability. Variable and normality test need not to be done. Directly we can do it. So we'll start with the control chart. You can see here and attribute chart, and then we'll start with a simple chart called C chart. C chart is only count chart. You can see here. So this is the EXHQC. I think we have already taken this one, and now blemish is the data. Okay, let me go back. That we have already taken that, and here in this case C9 alone we are taking it. Let's do control chart and C chart. In the C chart we can take that blemish, give okay. You can see here it is just a plot the data. On an average we have 2 blemish in per sample. That's what it means. Per sample we have 2 blemish, and the maximum we have 7 and minimum we have 0. Remember, even if you have more than -1 from the calculated value, you will still get 0. This is C chart. But what is a better version is that U chart. Why? Let's see. Again, C chart and U chart come in the defect family. So we can just go to attribute chart and U chart, monitor the number of defect per unit when each item can have multiple defects. So again, I'm going to help, and in that you can just select the toys.mtw, and we can see how that variance is there. Okay, go to file, go to open worksheet, look in Minitab data sample folder. You can type toys. Okay. In the toys, we are measuring only defect and sample. Let's read the question again. In the control chart, we are saying that U chart. In the U chart, we have been, so a production manager of a toy manufacturing company, you want to measure the number of defect, okay, defect per unit of motorized toy car. You inspect 20 unit of toys and create a U chart to examine the defect number of defect in each unit of a toys. You want to use a U chart to feature the stride control limits. Okay, and subgroup is 1 or 2. Okay, 1 or 2 is there, and we can just take only the control chart. In that we will take defect as a one sample. Only defect we are going to take. So okay, so we'll take defect. Subgroup is, they have given the subgroup of 1 or 2. You can see here. Subgroup size is sample, right? We have given the samples. I will take sample because sample is getting deferred each time. And you can see that this has now test has only 4 limits, right? Any discrete data has got only 4 control, interpretation rule. You can see here each one has got 5.46 percentage. So this is pretty much 5.46 percentage. Each unit has got minimum 5 percentage. Each unit has got, right? You can see that this is an outlier, and rule number falling. Rule number 2 is falling down. This also is failing, right? You can easily get to understand that. So this is all about the U chart. We'll take one more example. If we have U chart directly from here, go to stat guide, and you can see the same typos also they have given. We'll see this example, and the file name is transcription. Transcription. Go to file. Go to one. We can take transcription. Okay, the pages, number of pages and number of typo errors. So for example, 3 typo errors in 30 pages, right? So we can also get to have the percentage also U bar, right? So how you can do, but I'm just doing it in, we can directly do it in Minitab, but I'm just showing it how it has been calculated U bar. So typos divided by pages, and maybe you can convert everything into number. So this is the number you have 0.1, 10%, 16% and all that, right? Okay, so let's do that. So control chart, an attribute chart, and then you have a U chart. In the U chart, we have a typos that is coming from the pages. And you see, I will continue to keep that 4 as a rule. That's okay. That's okay. This is all about 23%, 23.8 percentage we have defect in each page. If you take each page has got at least one figure of speech, 1/4 is having typo error, right? That's what it means. This is also way too high. And here in this case, 50 percentage, it's predicted that 53 percentage will have a upper control, 0 to this is very, very unstable process. Okay. And the same thing I will do that Laney P chart, right? Go to stat, and you can go to quality two, the control chart, and then attribute chart, and then you have a P, Laney P chart. Sorry, Laney U chart will do, because since we are doing it U chart, we'll finish off with the defect and we'll go for defective. So this is U chart, but we'll go for Laney U chart. So you can see here Laney U chart, and so Laney U chart briefing is given directly here. That also I will read it out quickly for you. Create the U chart that corrects the over dispersion or under dispersion. If you have too much samples and the sample ranging is very huge, then you can use a Laney U chart. Okay, so you can see here. So variable you have the same. Maybe I will take the examples if you have they have given any examples, or we can go with the same example. So medication error dot mtw, we will do it. We'll do the normal as well as we'll compare that with the U chart also as well. This is U chart normal, U chart and this one also. We'll do both of them. So I'm just closing it and just taking the sample of medication error. Go to file, sorry, close this, go to file and go to open worksheet and look in Minitab data sample, medication error. So, okay, this is a number of error and this is a patient. So you can see here, and here the dispersion, what is mean by dispersion? Here 5,000, here 9,000, here some cases we have only 7,000, 4,000, and the minimum we have, it varies a lot, right? For example, let's say, even if I take that calculator and this is column 1, even if I calculate quickly, what is the minimum, what is the maximum? Minimum, I'm taking it the patients. Minimum is 4,500 we have. So what is the maximum we have? Control E, 9,000, almost double we have, right? In that case, over dispersion will naturally will take place, right? So what will happen? We will do that the Laney U chart. Go to the stat and control chart, and then attribute chart, Laney U chart. And of course, this is an error occurring in patient U chart, and then I'm just giving it all the tests. Give okay, give okay. You can see here, this is very small percentage, like less than 1%, 0.6% only. But you can see here, this is not the sigma value, what you see here. And this is the outlier is there in the 23rd point outlier is there. The same case, what I will do, you see that range is between 0 to 2.5%, right? So you can remember that 0 to 2.5% we have the UCL, and then this is just 0.6%, less than 1% we have, right? So let's see the same in contracts with U chart. Go to stat and go to quality, control chart, attribute chart, and U chart. The same example I can do. I will give F3 and I will take error that is occurring in patients, give OK. See, here it is getting varied. So 0 is, and then we had 2.5, but here it's showing only 1, right? The over dispersion and under dispersion is controlling it, because we had the samples are getting varied, like double. 4,500 we had one case, and 9,000 we had another case. So naturally the over dispersion will take place. So therefore that is what the both chart are correct. But only thing is, because our sample is different, maybe if I put these two in one frame, right, you can easily understand that. So this is the reason why we are using, maybe layout I'll put it. So this is U chart, and now Laney U chart. Both are same data, right? We are taking samples here. We are taking sample count, and here mean are same, of course, 0.6 percentage. But here is getting the reason why this is getting varied, because the ore dispersion is getting correction is taking place in the ore dispersion. So therefore, one is giving so much outlier, one is giving that only one outlier, because of naturally it is there because of the natural, ore dispersion reason, right? So not because of the process is very bad shape and all that. That's the reason selecting the right control chart is also very important. Similarly, last thing we'll do for defective one. Defective, we have a choice of P chart and NP chart. We'll do quickly for that also as well. Let's go to, of course, go to stat and control chart and attribute chart, P chart. In the P chart, you can click on help menu, and this is P chart, P for proportion, and how much proportion is it. This is used only for defective, right? And go to example. In the example, suppose you work in plant that manufacture the picture tubes for television. For each lot, you pull some of the tubes and do the visual inspection and all that. So EXHQC, this is the same file Minitab uses most of the time, and we'll use that, and then we'll use that subgroup as this one, and we'll find out. So in our case, that reject is the one sample. Reject and sample, we are going to take it. Okay. And what I'm doing it, I'm just minimizing this one so that I can see the file name. QC1, reject and sample. So column C7 and C8, we're going to do it. So Gestat, and then you can go to attribute chart and P chart. In the P chart, we are going to do it reject. Reject is there in C7 and divided by C8. And then we are going to take all the 4 interpretation tests. Give okay. I'll delete this one. As you can see here, so 16.18, although it has only one outlier, that is okay. But 16.85 is too high of rejection, right? It is very, very high rate of rejection. And therefore, this process is not stable, and but still we have to bring the process and remove that outlier, everything, and then consistently we can measure, we can make it to a smaller percentage as such, right? This is on the P chart. And similarly, you can find one more samples here. You can see here the same unanswered call also they have given. We'll take that unanswered call. Look in Minitab data folder, look in Minitab. Okay, and unavailable. So how many calls, how many unavailable? So you can just go to stat. Of course, you can do the control chart, an attribute chart, P chart, and unavailable, how many calls we had, and you can give okay. You can see at 22%, although it has only one outlier, but 22 is very high. 22.64 is very high. And the maximum is ranging to 25. Minimum it is having like 19. So this is also very, very high assets. So the same thing, we'll take one last example of Laney chart. And you can see here, Laney P chart. We have already done that Laney U chart. Now we are doing it Laney P chart. So go to help. You will find an example, and you can find a like defective error, defective records, right? So you can go to defective records. Okay, so defective records. So you can see there, this is also having over dispersion. What is mean by that? For example, if you go to stat and basic statistic and graphical one, total records. I'm just taking this as a one, just to get to know that what is the minimum value. Minimum is 1000 we have, maximum is 3000, almost three times higher we have, right? Or dispersion will naturally will take place, right? So I'm just doing it quickly on that one. So now what I will do, this is what I just wanted to show, minimum and maximum. Yeah. Go to stat and go to control chart, and then you have Laney P chart and total defectives divided by total records, U chart, and then we test perform all the tests. Give okay, give okay. You can see here this is a 1%, less than 1 now 0.93% is a defect. Process is very much in control. If you do the same thing in U chart, let's see what happens. Okay, P chart, we are doing it normal P chart compared to Laney P chart. So we are doing it same F3 defective divided by total records, perform all tests, give okay, give okay. So this is also same, but it's detecting that over layer. So if you compare that tool, I mean editor, and that if you compare that tool, so this is a normal P chart and this is the Laney P chart. The same mean is same, but due to dispersion, this shows that 1.8%, but here it shows 1.4%. In detecting this unnecessary, is a the control chart is reacting that there is an outlier, but actually this outlier is due to over dispersion. And similarly, you can see that U chart, which we did it before. This is normal U chart, and this is an Laney U chart. So all the Laney also we did it, like P chart, Laney P chart, U chart, Laney U chart also we have done. Right? This is how we can easily do it. And the last and finally, if your data is a variable data, we also have a choice to do it in the the box Cox transformation that we will see in upcoming videos. All the seven chart, Laney U chart plus Laney U chart, Laney P chart, all that we have done it. All the one which we have directly taken from Minitab and we executed. Remember, few things. There are seven control chart. I'm going to the summary. Seven control chart, and three are coming from the variable chart that is called continuous data. Four are coming from attribute chart. And then you also have additional chart like rare chart, Laney chart, Laney P chart, U chart, and all that. I hope you find this video useful. Please do like, share, subscribe my channel. You have wonderful day ahead.